Year 7, Introduction to Algebra, Lesson 2, Forming Simple Expressions. We're going to start by reviewing some of the basic principles of algebra. So, one of the ideas behind algebra is that we can use letters to represent numbers or numerical values. So if I think of a number, I could call that number a letter. Now, I could call that number n. I could call that number p. I could call that number a. I could call that number capital A if I wanted to. The most common letter you will see in algebra is the letter X, and we write it, and you may have seen this, as a curly X, like that. Have a go at writing that down. Now, let's look at how we can simplify each of the following statements. So number 1, A add A. Now you may have seen this with the quad air activity. If we have an A add another A, well, we have 2 lots of A. A little bit like if we have 5 add 5, which is equal to 10, or 2 lots of 5. Now, what happens if we have A add A add A? We have 3 lots of A, like that. And it's important that we write the number first. 3 lots of A, 2 lots of A. We never write A2 or A3. So here we have 5 lots of A, and we can simply write that as 5A. And you'll notice that we don't write the multiplication sign very often in maths when we're dealing with algebra. Partly it can be confusing. It can look like an X sometimes when it shouldn't, so we tend to leave out the multiplication symbol. Now, let's look at the next problem. Can we simplify A plus B? Now, you will have seen that from your quad air activity that we can't simplify A plus B. Now, why can't we do that? It's because A and B are what we call unlike terms. And you'll look at what happens when we have like terms and unlike terms a little bit later on. Here, if we look at example 2, again, these terms here are like terms, and in example 2 as well. And because they are like terms, here and here, we can simplify them and collect them together. So in example 3, look again, A and B are unlike terms, so we cannot simplify them. Some people try and write AB, but that means something else. AB means A times B, so it's not the same thing. Now, look at point 4. There are other ways in which we could express A plus B. We could express it as B plus A, because both of them mean the same thing, and you know that addition is commutative, which means you can add terms in either order. Now, number 5 often catches people out. Can we simplify lowercase a plus uppercase A? The answer is no. This is because, even though in English they mean essentially the same thing, when we're dealing with algebra, when we're dealing with maths, they are different terms. They are not like terms. So capital A would mean something different to lowercase a, so we cannot simplify lowercase a plus capital A, and we must be careful to use the correct letter when we're dealing with algebra. Now, let's look at the last example. You will notice that if we have 2 lots of something, we write 2A or 2X or 2P, 3 lots of something, 3X, 10 lots of something, 10A, for example, etc. But if we have 1 lot of something, we would just write A, or X, or N, or Y, etc. We wouldn't write 1A, and that's just for simplicity. There's no need for us to write 1 lot of something, because it's implied when we just see the letter by itself. Now, it's not entirely wrong to write 1A algebraically, but it's unnecessary. We don't need to do that. Now, we're going to have a look at forming expressions. We'll talk about what this word expression means in a little bit more detail after we've done this activity. But let's start by thinking of a number. What could we call this number? Now, we could call this number A, we could call it X, we could call it P, we could call it N, etc. The only letters we do sometimes avoid are L, because it looks a little bit like a 1 sometimes if it's lowercase, and O, because it looks like 0, so it can be confusing. But we can use almost any other letter that we want to use. So let's work through how we would set up these expressions. So number 1, I think of my number. I'm going to call my number x, and I'm going to add 3 to it. That creates the expression x add 3. Now, if I wanted to, I could write 3 plus x. That might be a little bit less obvious, but it is actually the same thing in this example. Number 2, I think of a number, I'm going to call it n, and I subtract 7. N, so take away 7. Now we're going to leave it as n take away 7 for the moment. We're not going to try and rewrite it in another way. Number 3, I think of a number, I'll call it p, and I multiply it by 5. This gives me 5p. Number 4, I think of a number, I'll call it m, and it's added to a different number. Well, I'll call that number n. So that gives me m plus n, or, if I want, n plus m. Doesn't make any difference, they both mean the same thing in this case. Number 5, a number, I'm going to call it x. I multiply it by 4, well that gives me 4x, and then we add 6, 4x plus 6. Now you could rewrite that as 6 plus 4x. Again, addition is commutative, you can add in any order. Now, a number, let's call it a. We subtract 3, so that's a take away 3, and then we multiply by 7. Now a lot of you will possibly want to write down a minus 3 times 7, and I want you to think about why that's wrong. It's wrong because of BIDMAS. BIDMAS would then tell you to do the 3 times 7 first, and that's not what happens here first. We do a number subtracted by 3 first. So what could we try and do to fix this? Well, we could put brackets round a minus 3, and then that is a bit better, but it's not the best answer. The best and neatest answer we would have is to have the 7 outside the brackets and then a minus 3 like that. So in algebra, this definitely means a minus 3 first, so we're doing BIDMAS, a take away 3, subtract the 3 first, then multiply by the 7. So we have the 7 up at the front like that. Number 7, a number divided by 2. I'm going to call my number x. Now, some of you might want to write x divided by 2, but again, in algebra, we tend not to use the division symbol if we can help it, and it's neater for us to write x over 2, a little bit like a fraction, or we could write a half x, which means the same as x divided by 2. So the best answers are these answers here. Number 8, I think of a number, let's call it p, and I divide my number by 8, so that's p divided by 8, and then I add 4. So there we have it. Now, some of you will try and put brackets in here, you don't need them. BIDMAS tells you you've got to do this division first before you add the 4. So there's no need to put brackets around the p over 8, it will automatically happen first. Number 9, a number, let's call it a, is multiplied by 3, so that gives me 3a. Then we subtract 6, so let's write 3a subtract 6, and then we divide the result by 10. So I'm going to put the whole thing over 10. Don't write 3a minus 6 divided by 10 on one line. This is the correct way of setting it up. And if you want to, you can even put in a pair of brackets here around the 3a minus 6, just to be very clear that that happens first before you divide by 10. Number 10, a number multiplied by itself. So let's call my number x. Now if I want to multiply x by itself, I'm doing this, x multiplied by x. And hopefully you know that that means x squared. Some people might try and write x, but that's not really the neatest way of doing it. We would have to write ab if it was a number multiplied by another number, But because the numbers are the same, x times x, the best answer here is x squared. So number 11, a number multiplied by a different number. Well, if I call my numbers a and b, a times b, the best answer is ab here. Number 12, a number subtracted from 12. Now, watch the wording here carefully. A number subtracted from 12. So it's not a number subtract 12, it's being subtracted from 12. So it needs to be 12, take away the number, which I'll call x. And then the last number question, number 13, 20 divided by a number. Again, that's 20 divided by the number, which we'll call p, which is not the same as p divided by 20. Division and subtraction are not commutative. You can't do them in any order. The order matters. Now, one last thing. Do you have to write the answers out alphabetically? Now, it's important to remember that AB is exactly the same as BA. There's no mathematical difference. So no, you don't have to write the letters out in alphabetical order when you're setting something up for an expression. However, it can be really helpful later on when we go on to collect terms in expressions to have them written out in alphabetical order. So there's nothing wrong with having them mixed up, so not in alphabetical order, but it can help you a lot if you write your terms out in alphabetical order later on. Now, the last thing we're going to do is make sure we understand what an expression actually is. And an expression is a mathematical statement. So in all these 13 questions, we have created mathematical statements. So a number multiplied by itself, x squared. A number add 3, x add 3. These are all mathematical statements. So x plus 3, 2p minus 7, 5 brackets, a take away 2, 3m. These are all examples of expressions, and it's important that you understand that a mathematical statement or an expression just tells you what to do with your number, which is being represented by a letter. Now, each part of an expression is called a term. So here's a term, here's a term, here's a term, here's a term. These are terms, and this is a single expression that consists of a single term. So parts of an expression are called terms. So it's important that you understand what an expression is, and it's important that you understand what a term is. Sometimes an expression might consist of just a single term like that. Other times an expression might consist of multiple terms. You're now going to work through, from the textbook, page 109 to 111, exercise 1M, and when you finish that, exercise 1E. The answers are present for you to check your work. Make sure that you do the questions first and then check your answers. I would advise work through exercise 1M first of all, check the answers, and then do any corrections that you need to, highlight any questions for which you need help on, and then work through exercise 1E afterwards, and then check your answers for 1E. Make sure you complete any corrections and don't leave any questions uncorrected before the end of the lesson.